So now we are going to solve an assignment problem. So basically, this is the question. You have to solve the assignment problem for the given data, and this is the given data. So what we have been given over here is these are sub-assemblies. So I'm just going to call them S1, S2, S3, S4. Okay, and these are the contractors C1, C2, C3, C4. So the problem is to assign sub-assemblies to contractors such that the cost is minimized. Okay, and what is given inside this matrix is the cost of allocating a sub-assembly to a contractor. So for example, the cost of allocating sub-assembly 1 to contractor 1 is 15. Likewise, all the other costs are given in this particular matrix. Now, this is an assignment problem. So in an assignment problem, both the demand and the supply are 1. Unlike in a transportation problem where we have got different units for demand and supply. But here, we just have to allocate one job to one machine, or in this case, it is one sub-assembly to one contractor. So it's one to one. So therefore, the demand also becomes 1 and the supply also becomes 1. So there is no need for us to write the demand and the supply, considering that they are 1 in all the cases. So what do we have to do? How do we have to solve the assignment problem? We have to, first of all, reduce the given matrix. So I'm going to call this as a matrix because it's written in matrix form. So reduce the given matrix. Now let us see how to reduce the matrix. So first of all, let's construct the grid again. So this is a 4 by 4 matrix. So I'm just going to construct a 4 by 4 matrix. Okay, so this is the grid, and now let's start with the calculation. So first of all, what we have to do is we have to start our calculation row wise. In each row, we are going to check which is the minimum element. So for example, in row 1, the minimum element is 13. So this 13 has to be subtracted from all the elements in that particular row. So 15 minus 13, 2, 13 minus 13, 0, then 14 minus 13, 1, then 17 minus 13, 4. Likewise, we are going to proceed ahead with all the other rows. So in row 2, the minimum element is 11. So we are going to subtract this element from the remaining elements. So 15 minus 11 is 4, and again 13 minus 11 is 2. And similarly, we are going to proceed with the third row. Here the minimum element is 10. So this is 3, 2, 0, 1. In the fourth row, the minimum element is 14. So again, we will subtract. Now, after doing this, what we have to do is we have to check whether each row and column has a 0 in it. So let us start the process of checking and tick mark if a particular row or a column has a 0, and if it doesn't, we will mark it with a cross. Okay, does row 1 have a 0? Yes. Row 2 has a 0? Yes. Row 3 has a 0? Yes. Row 4 has a 0? Yes. Okay, now let's start with the columns. Does column 1 have a 0? Yes. Column 2, yes. Column 3, yes. Column 4, that's a nil. So here there is no 0 in column 4. Okay. So because of this, what we have to do, we have to now further reduce the matrix. So let us see how we are going to further reduce the matrix. So once again, I am going to construct first 4 by 4 grid. Okay, and now we are going to again start with the process of subtraction. So this time we are going to subtract the minimum element in each column from the elements of that column. So in the first column, the minimum element is 0. So if I subtract 0 from all the other elements, this particular column is going to remain the same. Similarly, here the minimum element is 0. So now if I subtract 0 from everything in this column, once again, the elements in that column are going to remain the same. So same procedure I am going to follow for column 3. The minimum element is 0. If I subtract this 0 from all the other elements, again, we are left with the same column. And now we will see the fourth column in which we did not have a 0. And that is why we are performing this next step. Here the minimum element is 1. So I'm going to subtract this 1 from all the remaining elements. So this gives me 3, 1, 0, and 1. Okay, now let us just check whether each row and each column has a single 0 in it. So row 1, yes, row 2, yes, row 3, yes. If it has more than 1 0, that's also all right. But minimum 1 0 must be present in the row and the column. Similarly, in this column, we have a 0. Here we have a 0. Here we have 0. Here we have 0. So now we have a 0 in each row and in each column. So it is now time to make an allocation in our row and column. Fine. So I'll just pick off these tick marks. All right. Now let's see how we are going to make the allocation. So we have to start the process by checking for the row which has exactly 1 0 in it. So if I look at the first row, it has 1 0 in it. And this particular 0, I have to mark it with a box. Now in assignment problem, box indicates an allocation. Okay, what is the meaning of allocation? That means the machine or the job which are assigned to that particular position, right? In this case, this is the first sub-assembly. This is the second contractor. So we'll come to the optimal solution later on. But right now it's like saying that sub-assembly 1 has been allocated to contractor 2. Okay, now we will proceed in the same manner and we will check for again a row which has a single 0 in it. So in the second row, I have got a single 0, so I mark it with a box. Now, one more thing which you have to remember is if there is any 0 in the corresponding column, that means whichever column we are looking at. Suppose, for example, we mark this with a box and now we are looking at this C2. So in this C2, if we have any other 0, then that 0 has to be marked with a cross. Okay, so these are crossed zeros. This is an allocation and these are cross zeros. Now that we have followed the procedure for the first 2 rows, let's go to the third row. In the third row, we find that there are 2 zeros. So I'm going to skip this and then I'm going to go to fourth row, which has 1 0. So I'm going to make an allocation in this single 0. And now you can see that in this particular C3, we have got another 0 in the corresponding column. So what I'm going to do is I'm going to mark this with a cross. Right? That is what I was talking about. Once we make an allocation, if there is a 0 in the corresponding column, then we mark it with a cross. Okay, now I'm going to again continue the process. I can either now check row-wise or column-wise, but I need to have just 1 0 either in that row or that column. So let us say if I go column-wise, here no more zeros are there, here no more zeros, no more zeros. And finally, we have one unmarked 0 in column 4. That one I'm going to mark it with a box. That means an allocation. Okay. Now, once this is done, you are advised to revisit the part of the video where you feel that you have not followed. So you can keep watching several times until you understand the procedure. So once this particular allocation is done, what you need to do is now you need to check whether an allocation has been made in each row and in each column. So let's just do that. Let's check it. Okay, so in row 1, yes, we have an allocation. Remember, allocation means a box. Row 2, we have an allocation. Row 3, we have an allocation. Row 4, we have an allocation. Then column 1, we have an allocation. Column 2, we have an allocation. Column 3, we have an allocation. And column 4 also, we have an allocation. So this means that we have successfully made allocations in each row and in each column. So basically, what did we do? We have allocated the sub-assemblies. So sub-assembly 1, sub-assembly 2, sub-assembly 3, and sub-assembly 4. And we have allocated these to contractor 1, 2, 3, 4. So what is the assignment policy? Sub-assembly 1 allocated to contractor 2. Sub-assembly 2 allocated to contractor 1. Sub-assembly 3 allocated to contractor 4. And sub-assembly 4 allocated to contractor 3. Okay, so this we can call as our assignment policy. But now we need to calculate the corresponding value of the cost. So this cost is Z equal to, we are going to revisit our original matrix and extract the costs from there. So we can see that the cost over here for the first one in this particular case is how much? 13 plus the cost for the SA2C1. So that particular value is 11 plus we can see for SA4C3, the cost is 14 plus last one SA3C4, the cost is 11. So how much does this come out to be? 13 plus 11, 24, 38 plus 1, and that is 49. So these are all the steps involved in solving the assignment problem. So you can revisit whichever portion you want. If you have understood, then just write in the comment section understood. And if there is anything you wish to see again, then you can always replay that section of the video. Thank you.